Hello everyone, today we are going to solve this very hard question from Official Guide to GMAT. Question number 186 on OG 2022 or PS04711 if you want to look it up in your version of Official Guide. We are going to solve it with three different approaches, and please stay tuned till the end where we talk about three key takeaways that we can get from this question. The three approaches that we are going to follow are: number one, pure math approach. This is a word problem, and the word problems can be done in several different ways. However, we are going to solve this particular one with pure math by using minimum and maximum approaches. The second approach we are going to take is pure logic. We are not going to apply that much math or equations. We are just going to use extreme logic, break the problem down into simple understandable steps and solve it with pure logic. And finally, we'll look at a third approach where we kind of mix and match the math as well as the logic approach and somehow get to the answer. Towards the end, I will talk about which approach is better and what is recommended for the exam. So stay tuned till the end to understand which of these approaches is recommended in the exam. Obviously, before we get into solving the problem, we have to read the question first and understand it. So let's look at the question. We are given that there are 64 classes and there are 37 teachers who are going to teach these 64 classes. However, there are some conditions. Each class had no more than one teacher, and also that each teacher teaches at least one class and no more than 3 classes. It is also given that the number of teachers who teach 3 classes is n, and we are asked to find the minimum and maximum values of n. So let's write down what we are given in the question with some assumptions. So we are given that there are 64 classes and 37 teachers. Obviously, there are more classes than the teachers, so there would be some teachers who would end up teaching more than one class. That is self-evident. We are also given that each teacher teaches one class, but no teacher teaches more than 3 classes. So let's write that down. Let's assume the teachers who teach one class as X, the teachers who teach the second class are Y, and teachers who teach the third classes is already given to us as N. Since the number of teachers is actually 37, we know that X plus Y plus N would be 37, and we are also given the number of classes is 64. So X teacher will teach one class each, so they will teach X classes. The Y teachers would teach 2 class each, so they will teach 2 Y classes, and the N teachers would teach 3 classes each, so this will be 3n equals the total number of classes, since we cannot teach more than 64 classes. So this will be the basis of our method 1 and method 2. We have started with these two equations and we are going to continue using them in method 1. Okay, so on further scrutiny of these two equations, equation 1 and 2, I see that I have 3 different variables, x, y and n, and I have only 2 equations. The first thing I would do in situation like this is at least try to eliminate one variable and express 2 variables in terms of each other. And to do that, I see that if I subtract these two equations, x will cancel off and I will remain with y and n. So I'm going to do exactly that. I'm going to do equation 2 minus equation 1, and this will result in y plus 2n equals 27. From here on, we are going to solve this method into 2 different forms. One is to express everything in terms of y. So n will be equal to 27 minus y by 2. And the other is to express everything in terms of n. So y equal to 27 minus 2n. And the reason I'm doing that is so that you understand that either way is fine as long as you set up the equations correctly and then solve it correctly. From here on, I'm going to apply the same basic concepts I used in my minimum and maximum strategy video. If you haven't reviewed that video, I encourage you to look at the link above or look in the description for a link to that particular video. To save time here, I'm not going to get into the basics. However, solve it as fast as I can. So we know that n max would be possible when we have y as minimum and n minimum when we have y as maximum. Now, what is the minimum possible value of y? There could be 0 teaching 2 classes, and there could be x teachers teaching 1 class only, and then there could be n teachers teaching 3 classes only and 0 teachers teaching 2 classes. So it is possible that y minimum is 0. So when I take this y minimum, when I'm trying to solve this equation and I take y minimum equal to 0, I get n max max as 27 by 2. Now that is just not possible because I cannot have one teacher teaching a fraction of the class. 27 by 2 is 13.5. So this scenario is definitely not applicable. So the next value I will take would be y minimum equal to 1. And when I take y minimum equal to 1, I get n max equals 13. When I look at the possible values, I immediately see 13 as the only possibility in choice number A, and this is where I can completely stop all the work I am doing, mark that as a choice and move on because I've already figured out n max. I'm not going to do that here obviously and continue to solve the question so that you understand the conceptuality of solving it through and through. So I have figured out n max, and not only n max, I have also figured out y minimum. Now we have to also find n minimum. So for n minimum, we are going to look at this equation. Is there a limit on maximum number of teachers that can teach 2 classes? The only limit is from the equation itself, because if y max is more than 27, then n minimum would be negative, and you cannot have negative number of teachers teaching any classes. So the maximum value of y could be 27, which means you would have 27 minus 27 by 2 equals 0. So y max equal to 27 and n min equal to 0. This is your other set of equations. As you can see, n minimum also follows choice number A. Okay, so we are going to follow very similar logic when we express the equations in this way, where y minimum equal to 27 minus 2 n maximum and y maximum equals 27 minus 2 n minimum. Now to find maximum value of y, we can make minimum value of n as 0, and we will immediately get maximum value of y is 27 and minimum equal to 0. And to find the minimum value of y, you can put y minimum equal to 0 and get n maximum as 27 by 2, which is not possible, and then try again with y minimum as 1 to get the maximum value of n as 13. You still get the same answer. What I wanted to demonstrate here is no matter how you put the equation, if you are thinking through it logically, you will get the same answer. Now let's look at the method 2, where we do away with all the math and only use logic to solve this question. So in this approach, we are only going to think everything logically. So first, let me draw about 64 classes. Alright, so here is how my 64 classes look. The dot dot means a jump between C4 and C37, but we have 64 classes. And now let's start filling each of these classes with the 37 teachers, because we know that each teacher gets one class. This will be my first go of filling T1, T2, T3 all the way to T37, right? So I have filled the first 37 classes with the 37 teachers I have. Now I have another 27 classes left, and I can start filling those 27 classes again with T1, T2 all the way to T27. In this particular scenario, as you can see that not a single teacher has 3 classes, right? We have T1 to T37, each teacher getting one class, and then T1 to T27, teacher number 1 to 27 getting another class. So not a single teacher got 3 classes. This immediately tells us that the minimum value of n would be 0, because you could have a scenario where the max class each teacher gets is actually 2. Okay, now let's try to figure out the scenario where some teachers do get 3 classes, and what is the maximum number of that. So I will do that differently. This equation doesn't change, where the first 37 teachers got one class each. For the rest of the 27, I am going to start giving each of the next teachers 2 classes. So that means C37 would be T1 and C38 would be T1 as well. C39 would be T2 and C40 would be T2 as well. I'm going to start writing this down here. So T1, T1, then T2, T2, right? So T1 had actually gotten one class before as C1, and now T1 is also getting 2 classes, C37 and C338, making the number of classes T1 got as 3. And as I continue, I know that there are 27 classes. Now, this is a pair, right? I'm assigning 2 classes to each teacher. Eventually, I will be able to assign only 26 of such classes to teachers, which will be T13 here. And there will still be one class remaining, which will go to T14, but it will not be a pair. right? So T14, the teacher 14 would only get 2 classes. Since I have assigned 26 classes and I was assigning 2 classes per teacher, the number of teachers that got assigned these classes would be 13 pairs, right? So this means 13 teachers. We also have to remember that these 13 teachers already had 1 class each before, and now they have gotten 2 additional classes. So this 13 teachers have 3 classes each. So n maximum is equal to 13, and this also gives us A as the answer. As you can see in this method, I have applied almost negligible math and solved everything with the logic. Now let's look at the approach where we kind of mix and match both math and logic to arrive at the answer, and then finally we will look at our key takeaways. What is the best approach to solve problems like this? Okay, when we try to mix and match, it's not as difficult. We know that there are 64 classes and we have, let's say, already given 1 class each to 37 teachers. This means that there are 27 classes that are left to be assigned, and however we assign it, each teacher would get either 2 classes or 3 classes. For 3 classes, we would have to assign 2 classes to each of the teachers. So some teachers would get 2 classes and some teachers would get 1 class. Now let's assume the teachers who get the 2 classes, the number is represented by n, because those teachers have already gotten this 1 class in the first 37. Since they are getting the 2 classes now, the total number of classes they get is 3. We are given that the teachers who actually taught 3 classes is n, so that number is 2n, and plus the teachers who get 2 classes, and in this set of 27 they would get 1 class each because they have already gotten first class in the first 37, would be y. This is equal to 27. We come back to the same equation that we did in the statement number 1. However, here we got to this equation through logical approach rather than equation 2 minus equation 1 approach. Here we can apply the minimum and maximum method just like method number 1 and figure out that n max equals 13 and n minimum equals 0, which will give us statement A as an answer. So we have looked at 3 approaches. The question is which of these approaches is the best and you should apply in the exam. Let's look at them one by one. So first important thing that you must understand in problems like this is word problems are very common in GMAT. They are some of the most difficult problems in GMAT, and they can be solved in either ways. They can be solved through logic or pure math. Sometimes you may want to do a mix and match of those approaches. Whichever works for you best is okay. There is a debate around should you use logic or should you use pure math, and here is the thing. Pure math is a very generic approach that applies to all word problems. If you have practiced enough and you are able to apply pure math to all the word problems, life would be much easier for you because it is a generic set of mathematical rules that applies everywhere. However, if you go through the logic approach, you would need a lot more practice because the way you apply logic to word problems is case by case basis. Some people would apply the logic like I did in method number 2 today. However, some people would apply a very different kind of logic to come to the same conclusion. And hence the logical approach, while absolutely valid, is very difficult to replicate across different word problems. The more you practice, the easier it will get to apply the logical approach. However, you cannot count on the logical approach and logical frameworks you have in your mind to always work. And finally, it is absolutely okay to do a mix and match. Just make sure your assumptions are right. You could start with a logical approach, translate that into a mathematical approach and solve the question. Just make sure that you're not making any mistake when translating from the logical approach to the mathematical approach or vice versa. And the most important takeaway here is it does not matter which approach you choose as long as you get the right answer. However, here is the most important key. Any word problem that you see from now on, try to solve it in both purely mathematical way and purely logical way so that you understand how each of those approaches would be applicable. The more you practice that way, the better you would become in solving word problems. And that would result in you getting the word problem correct, and also you not spending too much time in solving the word problems in the actual exam. I hope you found this video helpful. I'm always looking to answer any questions you might have. So if you have any questions, please leave them in the comment box. I personally respond to all the comments, and please do subscribe to my channel. All the best with your prep. Thank you.